Hello everyone, welcome to aplusbi. This channel is all about complex numbers, and in this video we're going to be solving a trigonometric equation with complex numbers. So we have cosine z equals 2, and we're going to be solving for z values. Obviously z is going to be a complex number because this channel is about complex numbers, but I also have another channel that focuses more on algebra, number theory, and trigonometry, tiny bit of geometry. Sorry about that. I'm planning to do a geometry problem. I think I found a good one. And that channel is called Cyber Math. That is cyber with an S. Maybe that's where you came from. And if you did, please say hi. So to solve this trigonometric equation, you can, look at different approaches. And more importantly, this is kind of weird, isn't it? Why? Because we have an equation. Remember that. The Pythagorean identity, the trigonometric version of that, right? What is it? Sine squared of something plus cosine squared of the same thing equals 1. This is true even when z is not real. Really. So what does that mean? If cosine z is equal to 2, I can actually plug it in, but I need to square it. So it's going to look like this. Sine squared z plus cosine z squared, which is 4, equals 1. And then from here, sine squared z is going to be negative 3. Uh-oh. How can sine squared or anything squared can be negative? It's possible in the complex world. And from here, you kind of need to consider two cases. Sine of z can be square root of negative 3, which is square root of 3i, or it could be the opposite because there are two numbers whose square equals negative 3. And these are those numbers. But what do you make of this, right? Well, let's take a look at the result from Wolfram Alpha. I'll show you that, and then I'll proceed or maybe continue with the solution. So what does Wolfram Alpha do? And I know when I called it AI, people said, no, it's not AI. It's just a large language model, whatever you call it, right? AI is very common these days, and people claim that, AI will replace humans, so on and so forth. But guess what? Wolfram Alpha gives you the following. This screenshot was probably taken, who knows, 2-3 days ago maybe? So it's fairly recent. Take a look. It's like cosine inverse of 2. What? What are you talking about? What is cosine inverse of 2? That's what we need, right? Exactly. And 2 pi n is pretty standard because you're just adding it to the equation. 2 pi ni or e to the power 2 pi ni is 1 in the complex world. So you can write 1 in this way. Okay? Anyways, so let's just say we go with this. Okay? We have sine z equals root 3i. Or you could also consider cosine z equals 2. So these two work together, right? So let's draw a right triangle, shall we? When you draw a right triangle, if this is z, your angle, cosine is supposed to be 2, so it's going to be like 2 and 1. And sine z is equal to root 3i, which means this is root 3i. Uh-oh, an imaginary triangle. Am I just imagining things? Well, this is not real, obviously. This triangle does not exist. But we can still work with it. Like, you can try to find maybe the arctangent of root 3i over 2. But here's what's interesting. If you look at this number should kind of look familiar to you. Did you recognize it? It is actually the cosine of 30 degrees, which you can write as pi over 6. But does that have anything to do with this problem? Probably not. I just wanted to mention that real quick. And now we're going to get into the actual real solution. Not the real solution in the real number sense, but this is what I'm supposed to be talking about. Okay? So let's go back to cosine of z equals 2. So how can I express cosine z? Like if I do arc cosine, we don't know what arc cosine of 2 is, but you can try a calculator. From here, z is obviously can be written as arc cosine of 2 plus something 2 pi whatever, and try to plug this into Wolfram Alpha, which is a good calculator. Sometimes it can't find the answer or expresses it in such a weird way. It's kind of automated, right? That's what LLMs do. They just automate things. They spit out what they memorized or were fed or whatever, Not to undermine their value, but of course they're good for certain things. But in the sense, I think we're still better than machines and models and all that stuff. So far, so good, right? Okay. So, and it's 2025. Towards the end of 2025, right? We're approaching the end. Can you believe that? The year is almost over. And I could barely adjust to writing 2025 in the dates, Anyways, How can you solve it? We're gonna need a special formula which comes from Euler. Thanks to Euler because he's the best and he's done a lot of great things, including the most beautiful equation in math. Do you know what it is? Look it up and hopefully I'll make a video one day. Maybe Monday, who knows? So let's go ahead and take a look. We're gonna go ahead and consider Euler's formula. Euler gave us a formula which is mind-blowing, by the way. I mean, a lot of times I think we underestimate the value of this equation. Let's take a look at this. If you have e to the z, what does that mean? It's just an exponential, right? Depending on the value of z, you can just write it. But what if you have something like this, e to the power iz, right? Or e to the power I theta. I mean, z here can be complex or real, but let's just go with theta because theta is an angle, which is the argument. So he said, and he did prove that this can be written as cosine theta plus I sine theta. I can't really tell you how amazing this is, because take a look at it. This is exponential, this is imaginary, this could be real or non-real, this is the Euler's number, this is trigonometric, and again, I comes up, which is such a beautiful, beautiful identity. I just want you to appreciate the beauty, okay? Now, how do we use it in our case, right? Well, the good thing is I have cosine theta. Okay, so then you can just isolate cosine theta and write it as e to the I theta minus I sine theta. Another identity that you probably haven't seen before, right? But so, wait a minute. What am I supposed to do with this? Replace theta with z. It's going to be e to the iz minus I sine z. Okay, I'm not going to put that in parentheses. A lot of times people are going to use parentheses. Sorry, I don't like it, and I'm kind of lazy. But wait a minute. Can I just set it equal to 2 then? And from here solve for z? Yeah, you wish, right? That is just wishful thinking. Because you have trigonometry, you have exponential, you're kind of stuck. You can't really solve it. It's really hard. Instead, we're going to do something really, really smart. We're going to try to get another equation that contains cosine theta and then use that as a system to solve for cosine. And you're like, what the heck is he talking about, right? Let me rewrite this. And here's what we're going to do. And this is the hocus pocus part of our solution. We're going to place theta with negative theta. Can we do that? Yes, because this is an identity. So you can do that, right? This is valid even for non-real values of theta. So yeah, you have all the freedom. When you do that, you're going to get I times negative theta, which is negative I theta by product. And then this is going to be cosine negative theta plus I sine negative theta. Beautiful. Now consider the fact that this is cosine, and cosine is an even function, which means it'll just absorb the negative, right? If you think about the unit circle, first and fourth quadrants, if you negate an angle, you get the same cosine. Easy, right? Hopefully you know that. Now with the sine though, it is odd. So sine is odd, cosine is even. And odd functions basically just spit out the negative, like x cubed is an odd function, isn't it? Okay, so it's going to look like this then. This is going to be cosine theta, but this is going to be minus I sine theta. Figure out or think about why. Okay, now we have this and we have that. If you put it together, what happens? You are able to get cosine theta. So let's go ahead and add these equations. Imagine you're adding them. E to the I theta plus e to the negative I theta. The signs are going to cancel out, or I sine theta. You're going to get the cosine theta twice. Divide both sides by 2. Ta-da-da-da. You're going to get the another beautiful identity, which is normally given, but I just wanted to, torture you a little bit here. I hope you don't mind, so that you can derive it on your own too. Like, just play with the formulas and try to come up with the formula yourself without looking, or maybe looking at the first few steps. That's really going to help you. The most improvement you're going to be getting from trying to write things down on a piece of paper with little or no help. Okay? So this is our cosine theta. And ta-da-da-da, guess what? This is going to solve the problem. Replace theta with z. So cosine z would be e to the iz plus e to the negative iz, which is the reciprocal, divided by 2. And guess what? You're supposed to set it equal to 2. Cross multiply, you'll get e to the power iz plus e to the power negative iz equals 2 times 2, which is 4. And then write the meaning. What does a negative exponent mean? It doesn't mean the number negative. It just means it is flipped. It's the reciprocal. Ta-da! Now, you can go ahead and call this something, maybe w. This is 1 over w, so w plus 1 over w equals 4. This is a quadratic equation. It will turn into 1. Multiply everything by w, w squared plus 1 equals 4w. And you can bring the for W here, put the 1 on the right-hand side, and complete the square because it's kind of fun to do. Add 4 to both sides, yes, because it's half of 4 squared. 2 squared is 4. So this becomes W minus 2 squared equals 3. Wait a minute, this should not be the right thing to do, is it? Well, yes, actually we're gonna get, okay, fine. W is not, is gonna be real. Okay, fine. That makes sense. So W minus 2 is just gonna be plus minus the square root of 3. And if you add 2 to both sides, 2 plus minus root 3. One thing to keep in mind, W is just gonna be positive in both cases because root 3 is less than 2. Makes sense? You can kind of split it up and say, okay, W can be 2 plus root 3, or W can be, and you can call them even W1, W2, like using subscripts if you want. Some people are obsessed with that type of thing. Anyways, these are my W values. But what is W? W is e to the power iz. So now we're going to go ahead and set it equal to this. Let me do one and you'll do the other. E to the iz equals 2 plus root 3. Now, how do you solve this equation, right? Well, easy. Here's what you need to do. First of all, multiply the right-hand side by the complexified version of 1, which is something that I talked about at the beginning. Remember, it's e to the power 2 pi ni, and then natural log both sides, and the answer will come out naturally. Let's natural log both sides. We're going to get iz equals ln. By the way, this is a real valued ln. 2 plus root 3 plus, and you're just going to be getting from here 2 pi ni. And remember, if you log a product, you're going to have the sum of the two logs, okay? And when you log this, of course, you're going to be getting 2 pi ni. This is not done because we still have to solve for z. You could either divide by z, or even better, oopsies, even better, you can go ahead and multiply by negative z, negative I, that's what I meant. Because what negative I does is, this will give you negative I squared, which is 1. So you can totally get rid of that and distribute the negative I. This gives you z equals, when you multiply, you're going to get this. Negative I squared is 1 again. So you're going to get 2 pi n. That's why we got that in the solution from, well, if you call that a solution, from Wolfram alpha minus I times ln 2 plus root 3. This is the part that Wolfram alpha calls the arc sine or cosine, whatever, right? Anyways, this is our solution and I think it's better. What do you think? And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you next time with another video. Until then, be safe, take care. Don't forget to check out Cyber Math and aplusbi, and bye-bye.